All right, guys, these are going to be the day 1 notes, the in-class notes for our chapter 5 lessons. So if you were absent or you needed a recap or to rewatch this, we've got this video available for you. We're going to talk about 4 different special segments in a triangle. The first one's going to be a median. When you think of median, we should be thinking of middle. So before we start drawing the triangle, what we did was we went through our first special characteristic that you're going to see in a median. And this special characteristic we're going to write down your endpoints are a vertex and a midpoint. Midpoint being that keyword median. So it's going to be at a vertex and a midpoint of the opposite side. Yes, writing of the twice there. Okay, so pause periodically so that you can get this finished writing down so I can make it as short of a video as possible. So over here on the triangle, we're going to name this triangle X, Y, Z. Our median is going to need to go from a vertex. So we have 3 different vertices, so we're going to have 3 different medians we'll talk about later on in other lessons. But we're just going to focus right now on drawing one median, the basic here. We're going to start at a vertex, and we're going to go to a midpoint of the opposite side. So we'll use our vertex Y over here. And so what we want to do over here, the opposite side segment XZ, we're just going to eyeball where a midpoint would be. And we'll just call this guy M. Now, whenever I look at this and I draw this segment in, all I see is a segment of a triangle. So you have to focus on that midpoint, what happens with the midpoint, so that you can see the main identifying characteristic when you see the picture of a median. What do we need to see? Congruent markings right here. Okay? So this is your basic, most simple picture of a median. Remembering that triangles are not always going to be, with the bottom side with the congruent segment. Sometimes you may have it like this. We still see a segment going from a vertex to a midpoint. So we see these 2 congruent markings, so we can say it's a median. Another characteristic and fun fact about this, this median, when you have a median drawn in this triangle, it cuts the triangle into 2 triangles, and we can see that, but they aren't going to be congruent. But fun fact, these 2 triangles, it's going to cut into 2 triangles with the same area. Then we want to make sure that in all of these we're seeing what's congruent or what's being marked. What are our markings meaning? These special things that we need to look for in these pictures. Here we have 2 congruent segments. So that's what the median does, creating 2 congruent segments with that midpoint. So here we have that segment XM is congruent to segment MZ. Remembering that when definition of congruency, if we have 2 congruent segments, what do we know about their measurements? They're equal. So we'll have the length of XM is equal to the length of MZ, or the measurement of them, the actual numeric value. Remembering the congruent segments are the actual physical segments, the lines that are drawn. Without the bars above, without the squiggly congruent mark, equal, these are numbers. Okay? That is our median. So let's take a look at our next one. In Mapa, which is what this actually spells, your Mapa goes down here, Seco over here. The A here is going to stand for angle bisector. And we should all know what an angle bisector is. We should know what it does. We should know what happens and what we're going to mark to show that we're bisecting an angle. So as a review, with this one, the only thing that changes is we're actually talking directly in a triangle, which we've seen with congruent triangles as well. So we're going to go ahead and put our main characteristic here. We're going to have a segment. And the segment, it's going to be a segment that cuts the vertex angle. And we're now going to be bringing in, instead of just saying it's going to cut the vertex, or it's going to cut an angle in half. we're using vertex angle because now we're dealing with two-dimensional polygons, a shape with an enclosed figure with 3 or more sides. So we're looking at vertices as our corners, not corners, okay? So get used to the word vertex. Vertices is plural. It's going to cut the vertex angle into 2 congruent angles. You're going to see a lot of symbols coming up in here. So we need to make sure we understand what all these symbols mean. 2 congruent angles. So on our triangle, we'll go ahead and name this guy over here, triangle TUV. And we're going to draw in our angle bisector. Now, obviously, it's going to have to come from a vertex, okay? And it's going to go somewhere else on the triangle, to the opposite side, but we're not focusing like we did on the median of finding a midpoint down here. We don't know exactly where it's going to wind up on the opposite side. What we're focusing on is the angle, the vertex, the angle that the vertex of the angle's in. We need to make sure that we are cutting that in half. Now, we're not getting out protractors and measuring. So the way that we need to show the reader that this angle, that the vertex U, angle TUV, has been cut into 2 congruent segments, bisected, is what we've always done, and we need to mark congruent angles. Okay, my line wasn't even straight there. But this angle bisector, we will call this segment US. So we need to make sure we have a point on each end. So now we can go and we can write in our, what happened. We marked 2 congruent angles. What's the big characteristic to look for in these pictures other than that segment going from a vertex to the opposite side? Your angle bisector are these 2 congruent angles. So we're going to see here that following the pen with me, we have angle TUS. So angle TUS will be congruent to, TUS is congruent to angle SUV. And again, definition of congruency, if we have, and I forgot to put my little angle guy in here. I love these erasable colors. So based on the definition of congruency, if we have 2 congruent angles, then their measurements, so the measurement of angle TUS, their measurements will be equal. And there's your angle bisector. The perpendicular bisector is going to be next. This is going to be the longest one. We have a lot of things to look at, a lot of things to identify and draw. Plus, depending on what kind of triangle we have, they may look a little different. So here we have perpendicular bisector. And we'll talk about our first, the very first main characteristic that we're going to have here. Well, actually, it's going to have both in there. You have 2 words, perpendicular and bisector. So we have to make sure that both of these things are happening in our triangle. So the first thing is your perpendicular symbol, upside down capital T. You're going to have a perpendicular line through a side's midpoint. So you have the perpendicular, there's your perpendicular on the name, and then it's going to go through a side's midpoint. There's that bisector section of it, the midpoint, just like in median. Okay? So I'm going to start in this bottom left triangle, and I'm going to save the top one for last for a reason. This triangle, let's go ahead and name him triangle PQR. So we want to focus first, let's find this, the midpoint, okay? Let's just go ahead and use the midpoint of segment PR or side PR. Again, like median, we're going to kind of eyeball it and make sure that we can tell the reader it's bisected with our congruent marks. Then we need to make sure that we draw this segment. We're going to name all these perpendicular bisectors and all 3 of these segment in O. This segment, we need it to be perpendicular to this side with the midpoint. So if we draw it towards a vertex, like we did before with median, it won't be perpendicular. So most of the time, you're going to see this actually not go to a vertex. Okay, your perpendicular bisector isn't always going to go into a vertex, and we'll talk about what happens when it does. So then we need to make sure that we draw our little 90-degree right angle box. So now we have perpendicular bisector. And again, we're naming our perpendicular bisectors segment NO. We'll go ahead and move on to the triangle on the right up here. And we're going to take a look at, we'll name it the same thing. We'll have triangle PQR. And we're going to do the same thing we did with the other triangle. Okay? Come on here to segment PR. We'll find, kind of eyeball the midpoint. We want to make sure we say it's a midpoint with our congruent segments. And then we're going to go perpendicular to that segment, PR. And I'm drawing the 90-degree box on the other side of the segment because I want you guys to understand it's not always going to be on the left side or the top or the bottom. You could have it on the left, you could have it on the right, you can even have it on both. Okay, you never know. But now we have our perpendicular and our bisector, and the name of this is going to be segment NO. Now, what's going to happen on this other triangle, the one that I saved for the last? Okay, we're going to go ahead and take the same segment PR, so we'll go ahead and name over here this P, these vertices P and R, and we're going to go ahead and draw that midpoint. Eyeballing that midpoint, we can go ahead and name them O now if we want to. Make sure we put our congruent marks in so that we see that we have a midpoint. What will happen on this triangle is a little different than the other two. When we draw our perpendicular bisector, this is going to be a special case. You're going to find this perpendicular bisector, make sure we have our 90-degree marking, actually coming out of a vertex. Is again going to be a special case. So if all of our perpendicular bisectors are segment NO, that means this triangle's vertex up here is the letter N. Now, what happens with this, again, special case here, we're going to wind up with two congruent sides. When it comes out of the vertex and goes perpendicularly and bisects the opposite side, you're going to have your special case. I'm going to put a little asterisk up here, and I'm going to write in isosceles triangle. This is going to be your special case. So we also have two congruent sides. Now, we had the description of a perpendicular line through a side's midpoint, but we want to make sure to include what happens in this special case. So if what I have here first with a bullet point and this special case right here, and if it includes the opposite vertex, it's an isosceles triangle. Okay? So if you notice it coming out of the vertex and going to the opposite side and it's perpendicular and it bisects, you have an isosceles triangle creating two congruent sides over here, segment PN and NR. Now we wrote in the previous characteristics also these things that are sticking out that we need to be able to see to identify which segment this is going to be. So on this next part, what I want to start off with is that word perpendicular. What we're going to notice is in all three of these, we talked about the perpendicular bisector as segment NO. So segment NO on all three of these, segment NO on all three of these is going to be perpendicular, and that's why it stayed consistent with which side was being bisected. Segment NO is perpendicular to segment PR on all of these. And what does this mean? Well, we're having troubles remembering what perpendicular lines create. And it's that 90-degree angle, that right angle. So follow my pen with this. We're going to notice here that angle NOP, or PON, I think in my answer key, I'll just stay kind of consistent here. Angle PON on all of these, PON, PON. All of these, angle PON, and angle RON on all of them, are going to be right angles. And here's your right angle symbol. Remembering, what does right angle mean? Well, we should know this one. We're pretty good at this. It's going to be equal to 90 degrees. So there's our perpendicular part of it. We're noticing these 90-degree angles. We're noticing perpendicular segments or lines. The next thing is going to be that bisector part of it, where we had on the median, where we had the midpoint down here. So when we had that midpoint placed on, we cut segment PR into two congruent segments, saying that segment PO and segment OR are congruent. So segment PO is congruent to segment OR. Again, remembering that when two segments are congruent, our measurements are equal. And in the rare case of this isosceles triangle, our special little case, I'm going to put that little asterisk again, making sure we realize it matches with only the isosceles triangle, we're going to end up with two congruent sides. So now we have on the isosceles triangle, segment PN is congruent to segment NR. Again, remembering that congruent segments are going to have equal measurements. Okay? That's our special case, and like I said, this is the perpendicular bisectors. You're looking for the 90-degree angle and the congruent segments all on the same side. The last one we're going to talk about is going to be your altitude. With your altitude, whenever you think of altitude, I know I had a student tell me, and I've had this before, it's like, what do you think of when you think of altitude? And I hear the trampoline park. Well, it's not a bad example. When you're on the trampoline and you're jumping up, what's increasing is going to be your height. So you're going higher up in the air, so you think of height. So with your altitude, what we're going to see is we're going to see a segment from the vertex, or from a vertex, we're going to segment from a vertex, and it's going to be perpendicular to the opposite side. So our first triangle, we'll start with the top guy here. We're going to name this triangle KLM. And we're going to draw our altitude. We'll use vertex L. And we'll just have all of our altitudes be named segment JL. So our other endpoint that's going to be perpendicular on the opposite side will be the letter J. So we're going to start this vertex, whichever vertex we're starting from, and we're going to go directly straight across the shortest path, straight across the triangle to the opposite side, creating a 90-degree angle. And this will create our altitude segment JL. Now the bottom left triangle is we're going to represent a right triangle. So let's go ahead and put our 90-degree angle in before we do anything. Well, wait a minute, doesn't that form a 90-degree angle? It does. So in a right triangle, you're going to have two altitudes that are actually going to be the legs of the right triangle. So we'll just represent one right here. We're looking at right here. This side is going to be our altitude. And we're naming our altitude segment JL. So here's J and here's L up here. And then this other vertex, we'll just go ahead and name M, just kind of stay consistent with the top triangle. So this is what an altitude is going to look like in a right triangle. Your third triangle over here is going to be it's going to be an obtuse angle. So we have an obtuse angle, so we're going to have an obtuse triangle. Well, depending on which vertex you're coming from, you may notice something different with your altitude. Here we had one right up against the line, right up against the side. Here we had it, somewhere inside of the triangle. Well, if I start up here at this vertex, okay, we're using vertex L that we're going to be drawing the altitude out of. In order to become perpendicular with this opposite side, we're going to have to extend this side so that we can, if we draw down to somewhere where it's on the triangle, we're not going to be perpendicular. So I know this guy's a little bit crooked on these notes. But we're going to want to go from vertex L straight down to create a 90-degree angle. So that would be our altitude, segment JL. Okay, so sometimes that altitude is shown outside, and you've seen this. Again, it's our height of the triangle. So when you find the area, you have to look for that 90-degree angle to figure out what the height is. So here we can just name this guy, this vertex K, and this one M. So our next characteristic that we're going to want to write in over here is going to be what we keep bringing up, that this altitude is the height of the triangle. Okay, we have the height of the triangle. And then here we don't have anything congruent. So we don't have any congruent statements to write in, but what we do have is our perpendicular segments here. So if we notice in each one of these, segment JL is perpendicular, that's our altitude. So segment JL will be perpendicular to, and each one of these, we could say is perpendicular to segment KM with this top one, but if you look down here at the right triangle, we don't have the K over here. So we could just say segment JL is perpendicular to segment JM. We can just use this little part too. So we could say perpendicular to segment JM. Remembering this creates 90-degree angles. So then we have our angle. Okay, we can start off with angle LJK. And we have angle LJM. These are going to be right angles, making sure that we understand this is equal to 90 degrees. Now, I explained these four segments as kind of a family. If you take a look at your perpendicular bisector, the two big things that stand out for characteristics of perpendicular bisectors, the 90 degrees and the congruent segments. Well, if you look up at median, we have that congruent segment part, right? So that's what median and perpendicular bisector share in common. Well, if you look at altitude and perpendicular bisector, they share that perpendicular, okay? So what I always like to say is that perpendicular bisector is if like a median and an altitude had a baby, because you get 50% from the biological mother and 50% from the biological father. So you're going to show both of these traits on the perpendicular bisector. When you look at the angle bisector, it doesn't share really any of these traits with the other three, so that's like the puppy dog in the family or the kitty cat in the family. We're not biologically related, we're not going to share any of those traits. So very quickly to go through, median, what are you looking for? That segment out of a vertex to the opposite side, we're looking for the congruent segments. Angle bisector coming out of a vertex to the opposite side with two congruent angles. Perpendicular bisector, we're looking for, it may come out of the vertex and may not, but what we're focusing on is the 90-degree angle, and the same side of that 90-degree angle, we have congruent segments. Your altitude, the big characteristic, is going to be the perpendicular, the 90-degree angle right there. Okay?